ఇవి ఇక్కడ టాప్ అంటే ఇవి కెమెరాలో ప్రాబ్లం ఏమవ్వదా ఇది ఇవి రెండు స్టార్ట్ చేయమని చెప్పండి నేను స్టార్ట్ చేస్తాను స్టార్ట్ చేయమని చెప్పండి నేను స్టార్ట్ చేస్తాను ఓకేనా ఏంటి స్టార్టా ఓకే సో హియర్ వీఆర్ గోయింగ్ టు డిస్కస్ అబౌట్ కైనమాటిక్స్ okay okay so here we are going to discuss about the kinematics and its problems. So here we have the problem 1, which of the following will represent the uniform motion. Here what is meant by first question, it is about uniform motion. What is meant by the uniform motion? The uniform motion is all about, it is the motion of a body in the absence of external force. In the absence of external force means if there is no force applied on the body, obviously you know that acceleration of the body is also zero. Acceleration is zero. Here, because I am saying here, if it to be in the case of the uniform motion, the force acting on the body should be zero, and we know that force F equal to ma. Here, for the force to be zero, the acceleration should be zero. That means here it means that if the acceleration is zero, that means it is moving with a constant velocity. We know that acceleration equal to change in velocity by time. Here acceleration is zero means a change in velocity is zero. Change in velocity is zero. That means there is no change. If there is no change, that means it is moving with constant velocity. So here as there is no change in velocity, so because for the acceleration should be zero, there should not be any change in the velocity. Here the change in the velocity should be zero, so it should move with constant velocity. So that means from this graph, this is the graph in between displacement and the time. Time is on x-axis and displacement as on y-axis. So here if you see the option A, here the displacement is increasing constantly like this with the increase of time. So here with the increase of time the displacement is been increasing. So what does it mean? So in equal intervals of time, equal displacement is increasing. The displacement is increasing in uniform manner. So in equal intervals of time, the displacement is increasing in an uniform manner. So here as the displacement is increasing uniformly, that means we know that velocity equal to displacement by time. So here as the displacement is continuously changing or been increasing with respect to time, here we can say that the displacement is increasing uniformly. So here obviously the velocity is also uniform. Here the velocity is also uniform or constant. So suppose if you see from the graph B, here in graph B, the graph B is in this manner. So here with the increase in time, the displacement is increasing up to some value of time t, and then if the time is increased, then this value of, suppose it has t naught, suppose if the value of time is increased more than t naught, then the value of displacement is again decreasing. So here the displacement is increasing and again decreasing with time. So here this is not uniform motion. Next in option C, you can see it has a straight line which is parallel to time axis, in the option C. So in the option C, you can see the graph like this, right? So here with the increase of time, the displacement is not changing and is remaining constant. That means the body is not moving. But in option D again, here in option D also the displacement is increasing, again it is decreasing beyond some value of t. So if you see from these options, in option A there is constant velocity, because as there is in constant change in the displacement. So here it is option 1 which will represent the uniform motion. So it is option A here. ఇది ప్రాబ్లం 2 and రాంగ్ ఇచ్చాడు. ఇది ప్రాబ్లం 2 and రాంగ్ ఇచ్చాడు. 3 కూడా రాంగ్. 4. Here in case of problem 4, in problem 4 here he has given a body is moving along a straight line path with constant velocity at an instant of time. The distance traveled by it is s and the displacement is d. So here the body is traveling in a straight line path. The body is traveling in a straight line path. Suppose let it be in between points A and B. Let it be in points in between the points A and B. The body is traveling from A to B. So here given if the body is traveling along a straight line path, the distance is given by S. Distance is equal to S. Then and its displacement is D. Displacement is equal to D. Suppose let us calculate the first value of distance if the body is traveling in a straight line direction. So if the body is traveling along this straight line direction, we know that distance is path traveled. So here the path traveled by the object in between the points A and B along a straight line is this, right? And also next it is displacement. The displacement is the shortest path in between 2 points. So in between any 2 points, here the shortest path is the straight line joining those 2 points. So here in between the 2 points A and B, the shortest path or the shortest distance is the straight line joining those 2 points. As the shortest distance is called displacement. So here the displacement is also the same straight line from A to B. So here in this case, if the body is traveling in a straight line direction, both the distance is equal to displacement. So it is option C, D equal to S. Next we have the problem number 5. In problem number 5, a body falls freely for 10 seconds. Its average velocity during this journey. So he is asking the value of average velocity. Average velocity. He is asking the value of average velocity. So here average velocity taken as velocity average. Here what it is we have to find. Next he has given the time t equal to 10 seconds. Time t equal to 10 seconds and small g, the acceleration due to gravity is 10 meter per second square. So he is asking the value of average velocity. We know that average velocity is equal to total displacement by total time taken. Total displacement by total time taken. So here in this case we don't know the value of displacement. So first you have to find the displacement. So from this he had said the body is freely falling. When a body or when an object is freely falling, its starting velocity should be taken as 0. So here this is a case of free fall. In case of freely falling body, starting velocity or initial velocity u is always 0 for a freely falling object. So from this we have an equation, s is equal to ut plus half at square. So here s is displacement, u is the starting velocity or the initial velocity, which is u is 0, and half a means acceleration with which the body is moving, t is time, we know that. So here as u is 0, So S becomes half at square, half at square. But as the object is falling only under the action of force of gravity, so if there is force of gravity, when there is force, there will be definitely acceleration. So here the body is falling or the body is moving under the action of only under the action of gravity. So here the acceleration caused by that force of gravity is acceleration due to gravity g. So here A becomes G because the acceleration with which the body is moving in this case is acceleration due to gravity, which is caused by the force of gravity. So it is G here. So S equal to half GT square. S is equal to half GT square. So here from this you can find that half G is 10, T is 10, 10 square, 100, 5. So it gives 500. 5 into 100, 500. So the displacement is 500 meters. So here the displacement S is 500 meters. Next we want average velocity. As we want the average velocity, we have already know that average velocity equal to displacement by time. Here now we got the value of displacement. We have already have the value of time t. So here average velocity is equal to the displacement by time. The displacement here is 500, time is 10 seconds, 500 by 10, 50 meter per second is the average velocity in this problem. So if the body is freely falling for a time of 10 seconds under the action of gravity, G equal to 10 meter per second square he had given. So he is asking to find the value of average velocity. You can find the average velocity like this. First you have to find average velocity equal to the displacement by time. Here the displacement can be found with the formula S equal to ut plus half at square. So here as the starting velocity u is 0, so S equal to half at square. As the body is falling under the action of gravity, so the acceleration caused by the gravity is g. So A equal to G if the body is only falling under the action of gravity. So here S is equal to half GT square. G is 10, T is 10, T square it is 100. So here 2 5 is 10, 5 into 100, 500 meters. So here the displacement S is equal to 500 meters. So next we have the average velocity equal to the displacement S by time t. S is 500 and time is 10. 500 by 10 gives 50 meter per second is the value of average velocity. Here in the problem 6 he had given statement 1 as this. Here he has given the statement 1 as speedometer of an automobile measures average speed of the automobile. Is it true? Here always the speedometer will always calculate instantaneous speed. That means speed at that particular instant of time. It is not about the average speed. So here the speedometer will always calculate instantaneous speed. That means speed at that instant of time. That means the speed with which he is traveling. But it will not show the average velocity from which he had started the trip. Okay. So here the speedometer will always calculate the speed at that instant of time. It is instantaneous speed. It will not calculate average speed. So the statement 1 is false. Next statement 2, the reason. Average velocity is equal to the distance, total distance by total time taken. We know that average velocity equal to the total displacement by the total time taken. It is not total distance by total time taken. Average velocity is always total displacement by total time taken. So here both statements are false. So it is option D here. So here, and this problem model 7 is very very important model. Here first you have to understand this model. Here this model is so so important. The problems from this model are so important. So here he had given a car covers the first half of the distance in between two places at 40 kilometer per hour. Here 40 kmph. 40 kmph mean 40 kilometer per hour, and the other half at 60 kilometer per hour. So the average speed of the car. So average speed of the car. So here average speed equal to, we know that speed equal to distance by time. So average speed equal to total distance by total time taken. Total distance by total time taken. Suppose the total distance S1 plus S2 by T1 plus T2. So here if you observe, the first half of the distance between two places and the other half. So here S1 equal to S2 obviously, because in the first half of the distance is equal to the distance covered by the car in the second half. So here the distance covered in the first half S1, the distance covered in the second half S2 are equal. So S1 is equal to S2. So it is, take it as S1 is equal to S2 equal to S. So S plus S by here T1. We know that speed equal to distance, speed equal to distance by time t. From this you can write time equal to distance by speed. Time equal to distance by speed. So here t1 equal to distance d1, that means s1 by speed, take it as v1. T2 time distance s2 by velocity v2. So here we have known again, for suppose take them as usual. So as s1 equal to s2 equal to s, I write it as s plus s 2s by, take s as common here, then 1 by v1 plus 1 by v2. S get cancelled. So it is 2 by v2 plus v1 by v1 v2. So it will obviously gives us 2 v1 v2 by v1 plus v2. So here v1 is 40 kmph and v2 is 60 kmph. So as we have already values here, v1 equal to 40 km per hour, v2 equal to 60 km per hour. So 2 into 40 into 60 by 40 plus 60. So from this you can obviously write 2 into 40 into 60 by 100 by 100. So zeros get cancelled. 2 4s are 8, 8 6s are 48. So answer is 48 kmph. Option A it is. Option A. So here in this problem, here you have to understand these type of problems well enough. Here given the car which covers half of the distance at speed of 40 km per hour and the second half of the distance at 60 km per hour. So here the distance covered in the first half is equal to the distance covered in second half. So S1 is equal to S2, take it as sum S. So here average speed equal to the total distance by total time taken. So S1 plus S2 by T1 plus T2. So as we have already known from the question, the first half distance equal to the second half distance, S1 equal to S2. So S plus S 2S by, you can take S by V1 plus S by V2. So S is common and 1 by V1 plus 1 by V2. SS get cancelled and 2 by, if you take this as like this, you can take like this as V2 plus V1 by V1 V2. So if this V1 V2 goes upwards, then it becomes 2v1 v2 by v1 plus v2, as we have already have the values of v1 and v2. If you substitute those values of v1 and v2 in this equation, we got 48 kmph, 48 kilometers per hour. So it is option A. నా వాయిస్ ఎలా వస్తుందో అండ్ ఒకసారి చూసుకోవచ్చా? Problem 8 is also wrong. సార్ ఒక నిమిషం, యాక్చువల్లీ నాకు నా వాయిస్ ఎలా వస్తుందో ఒకసారి వింటే నేను ఏమైనా ఇంకేమైనా నా వాయిస్ ఏమైనా ఇంప్రూవ్ చేయొచ్చేమో అనేసి మరొకసారి చూసుకుంటాను. ఓకేనా, అట్లేం లేదా? Okay. So here we have problem number 9. In problem number 9, he had given again a car moving on a straight road which covers 1/3 of the distance with 25 km per hour and the rest with 75 km per hour. Again he is asking the value of average speed. So here in problem 9, he is asking here again the value of average speed. Average speed. So here he had given v1 equal to 25 km per hour and v2 equal to 75 km per hour. 75 km per hour. So a car moving on a straight road covers 1/3 of the distance with 25 km per hour, and the rest means here the distance s1 is equal to 1/3 means s by 3, and the remaining means obviously 2s by 3. So s1 is s by 3 and s2 is 2s by 3. And you may ask me how we got 2s by 3. I think, and you may have know this, but if you don't know, once see here please. So here, as it is 1/3 of the total distance s, so it is s by 3. So the remaining will be s minus s by 3. Obviously it is 3s minus 2s, 3s minus s, 2s by 3. So again V average equal to total distance by total time taken. So here has he not given the value of time t1. So here time t1 can be written as from the previous case, s1 by v1 plus s2 by v2. We have the values of s1, s2 and v1 and v2. So here we have wrote t1 equal to s1 by v1 because speed is equal to distance by time. From this you can write time t equal to distance by speed. So because of this reason we have wrote t1 equal to s1 by v1 and t2 equal to s2 by v2. So s1 is s by 3, s2 is 2s by 3, s1 by v1. s1 is s by 3 by v1 25 and s2 2s by 3 by 75. And we know that s by 3 plus 2s by 3 is s, it becomes 3s by 3. 3s by 3 means 3 get cancelled and there remain only s. Here from this you can take s by 3 as common, then you will get 1 by 25 plus 2 by 75, SS get cancelled. So 1 by 3 into 75 plus 50 by 25 into 75. So here from this you can write, if this bring this 1 by 3, 3 to upward, then it becomes 3 by 75 plus 50, 125 by 25 into 75. So here 125 5 is 120, 3 into 75, 225 by 5. So obviously it will give us 45. So answer is option B, 45 kilometer per hour for the problem number 9. Here next we have the problem number 10. In problem number 10, he said that when a particle will when a particle return to its initial point, when a particle returns, suppose if the body or if a particle has started from this point O, after traveling or after traveling across different points, if it came again to the same point, then he is asking what about its displacement. So we know that its starting point and ending point is the same in this case. If the body has started or if the body had ended at the point where it had started, if the body had or if the particle had ended where it had started, obviously the starting point and the ending point will coincide, and the shortest path in between the starting and ending points is 0. So here obviously, as the displacement is the shortest path in between the 2 points, so here as the starting point and ending point are same, so the displacement is 0. So option A is true. Next, if you see option B, instantaneous speed is 0. It may or may not be 0. Here instantaneous speed means the speed at that instant of time. It may or may not be 0, but displacement is exactly 0. Next, see, distance is 0. Here the distance means the total path we have traveled. Here, while calculating the value of distance, we have to calculate this entire path which is traveled by the body. So here the displacement is more than 0. It is not 0. So next, D, average speed is 0. Average speed is also not 0 here, because the speed does not have any direction. It is a scalar quantity. Its average value is not 0. So here option A, displacement is 0. So here in problem number 11 now. In problem number 11, he has given a car moves from points A to B with a speed of 30 km per hour and from B to A with speed of 20 km per hour. And what is the average speed of the car? That means first the body or the car has started traveling from A, then it had reached to point B, and then after reaching to the point B, and again it traveled from B to A, and again it traveled from B to A. While it is traveling from A to B, it is with a speed of 30 kilometer per hour. 30 kilometer per hour. While it is traveling from B to A, its speed is only 20 kilometer per hour. So here in both the cases, the distance traveled is same. Here it traveled from A to B and again from B to A. It is traveling in between the two same points. So here the distance traveled while it is from A to B is equal to the distance traveled from B to A, but with different speeds of 30 and 20 kilometer per hour. So what is the average speed of the car? So again we have average speed equal to total distance by total time taken. So here total distance, so take it as S1 plus S2 by T1 plus T2. We know that while it is traveling from A to B, the distance, and while it is traveling from B to A also, the distance is the same. So here you can write S1 is equal to S2, S1 is equal to S2, and you can write again we know that T1 equal to S1 by V1, T2 equal to S2 by V2. So S1 is equal to S2, take it as some S. So it is S plus S, 2S by S1, S by V1 plus S by V2. 2S by, if you take SS common, 1 by V1 plus 1 by V2, SS get cancelled. 2 into V1 V2 by V1 plus V2. So it is 2 into V1 is 30 and V2 is 20. 30 into 20 by 30 plus 20. 40 into 30 by 50. 5 8s are 40. 8 into 3, 24 kilometer per hour. It is option D in problem number 11. 24 kilometer per hour. So here see, in case of problem number 12, in problem number 12, here he had given an object which is moving in a straight line along x-axis. Its distance from the origin is given by x equal to 10 t square. Here the distance x is given as 10 t square. It is not 10 t2, it is 10 t square. So here he is asking the value of average velocity in the time interval t equal to 2 seconds to t equal to 3 seconds. So first you have to find this problem is wrong and those options are అవి అక్కడ ఆప్షన్స్ రాంగ్ ఉన్నాయి ఇంకో ఆప్షన్ మార్చారు so we shall skip this one. Shall I drink this water? So here, in case of problem number 13, here problem number 12 options are given wrong. So keep it away. Next, problem number 13. Problem number 13 here given a particle covers half of its total distance with speed v1 and the rest half distance with speed v2. So its average speed in the complete journey. As we have known, again he is asking average speed is equal to total distance by total time taken. So here we have done in previously two problems in which the distances s1, s2 are equal. So if s1 and s2 are equal, we have got the average velocity VAV equal to 2v1 v2 by v1 plus v2. So here it is option C, 2v1 v2 by v1 plus v2. This formula we have done with the proof in the previous two problems. If you have any doubt, and you can check out those problems once. Okay. Again, problem number 14. It is based upon the formula what we have done in problem number 13. So here he had given a car travels with first half distance with speeds of 30 km per hour and the remaining half with 50 km per hour. So here V1 is 30 km per hour, V2 is 50 km per hour, but it had traveled equal distance in both the cases. So S1 is equal to S2 is equal to say some S. So he's asking find the average speed of the car. So again the average speed V average is equal to 2v1 v2 by v1 plus v2. So it is v1 is 30 and v2 is 50 by v1 plus v2, 30 plus 50. 2 into 30, 50 by 30 plus 50, 80. Again 2 fours. So 30 into 5, 150 by 4, which obviously will give out 37.5 kilometer per hour. It is option C. It is option C. Next you have problem number 15. In this problem number 15, select the incorrect statements from the following. Here in the statement S1, average velocity is the path length divided by time interval. He is asking to choose incorrect statements. So incorrect statement means average velocity is not the path length, it is the shortest path, or it is the shortest distance, or it is the straight line joining those 2 points. So it is not simply the path length, it is the shortest path. So obviously the statement 1 is false. Next, statement 2, S2. In general, speed is greater than magnitude of velocity. Yes, obviously, speed is always greater than magnitude of velocity. And you may ask why the speed is greater than velocity in most of the cases. So, speed equal to distance by time, velocity is equal to displacement by time. Displacement by time. So here the distance in general, if you travel in between any two points, you will travel across the straighter path in very rare cases. In most of the cases, you will travel across some path. It is not obviously straighter path. So here obviously in most of the cases, the distance or the path traveled is more than the shortest path. So distance in general is greater than or equal to displacement. Greater than or equal to displacement. In some cases, the distance is equal to the displacement if the body has traveled through the shortest path or the straight line in between those 2 points. So here in general cases, the distance is always more than or equal to displacement. So if the distance is greater than or equal to displacement, obviously speed is also greater than or equal to velocity. So in general cases, speed is more than velocity. In statement 3, a particle which is moving in a given direction with a non-zero velocity can have zero speed. Which is having non-zero speed cannot have zero speeds. It has non-zero velocity and definitely it will have some non-zero speed, because speed cannot be less than velocity. Speed is always more than velocity, because in between 2 points there is no shorter path than the straight line. So here the distance should always be greater than or equal to displacement. So speed is obviously greater than or equal to velocity. So it is not possible, because in statement 3 has given the speed is less than velocity. So which is not possible, it is wrong. Statement 4, the magnitude of average velocity is the average speed. So we know that the speed and velocity are two different quantities. Those are not equal. So here statement 1, 3 and 4 are incorrect. Only statement 2 is correct. But here in the question is asking incorrect statements. So 1, 3 and 4 are incorrect statements. It is option C. S1, S3 and S4 are incorrect statements. And this is one of the very important models of problems. Problem number 16. In problem number 16, he has given a body of mass m moving along a straight line, covers half the distance with speed of 2 meter per second, and the remaining half of the distance is covered in 2 equal time intervals with speed of 3 meter per second and 5 meter per second. The average speed of the particle for the entire journey. Suppose if the body has traveled from A and has to travel to point C, and point B is the exact center point of A and C. So here a body of mass m moving along a straight line covers half the distance with speed of 2 meter per second. That means it has traveled from the point A to B with a speed of 2 meter per second. Next, he has traveled the remaining half of the distance is covered in 2 equal time intervals. From B to C, it has traveled in 2 equal time intervals with speeds of 3 meter per second and 5 meter per second. 3 meter per second and 5 meter per second. So the average speed. So from this you can say that while it is traveling from B to C, it has traveled half of the time with 3 meter per second, and it has traveled the remaining half with 5 meter per second. As he is traveling average speed, as he wants to find average speed, is equal to total distance by total time taken, obviously. So here total distance. Here the distance from A to B is equal to the distance from B to C. So here S1 is equal to S2, take it as some S, take it as some S, because the distance from A to B is equal to the distance from B to C, because he has said that it has traveled half the distance with a speed of 2 meter per second. So half the distance with a speed of 2 meter per second. So this is half and this is the remaining half. So S1 is equal to S2 here, and take it as some S. So here you want T1 and T2. T1 is the time taken from A to B. As we know that the time equal to distance by velocity, the distance S1 by velocity 2. So it is S by 2 meter per second. Next you want here so here it traveled with a speed of 3 meter per second for half of the time in between B and C. So for half of the time in between B and C, it has traveled the distance of take as suppose it has S2 and S3. Cut this and cut this part up to now. I will explain this part again. Cut this part, cut this part. So here take this distances up to this as S1 and up to this as S2 and this as S. So here from this you can have the time. So here the average velocity VAB is equal to S1 plus S2 by T1 plus T2 he has given. He has traveled from A to B with a speed of 2 meter per second, which is half of the distance, and the remaining half from B to C is first to travel for half of the time it traveled with 3 meter per second, and for the remaining half of the time it traveled with 5 meter per second. So here so the average velocity is equal to the sum of S plus S1 plus S2 by TAB plus TBC. TAB plus TBC. So first we know that the time AB, TAB is equal to the distance travelled S by velocity 2. Next, when it has to travel from B to C for half of the time, that means the time from B to C, TBC, for half of the time, TBC by 2 is equal to the distance S1 by velocity 3 meter per second. Next, the remaining half, TBC by 2, it has traveled the distance of S2 with a speed of 5 meter per second. From this you can have S1 equal to 3 by 2 TBC, S2 is equal to 5 by 2 TBC. So here as we know the distance from A to B is equal to the distance from B to C. So S1 plus S2 is equal to S. So S1 plus S2 is equal to, we can take TBC as common, 3 by 2 plus 5 by 2. So TBC into 3 by 2 plus 5 by 2, 8 by 2, which is equal to 4. So TBC into 4 is S1 plus S2. So here we have already know that we can write TBC equal to S1 plus S2 by 4. But obviously we have known that S1 plus S2 is equal to S. So S by 4. TBC equal to S by 4, and we have TAB equal to S by 2, and S1 plus S2 is equal to S, so it becomes VAB. The velocity average speed is equal to S plus, as S1 plus S2 is equal to S plus S by TAB is S by 2 and TBC is S by 4. So it is 2S by 4S plus 2S by 8. 2 into 4 8. So 2S by 6S by 8. So it is obviously 3 by 4s. So it is 2 into 4, 8 by 3 meter per second is the average speed. Option B. It is option B. So here first you have travel. First the half here, these model of problems are so important from the exam point of view. So here he has covered the half of the distance with a speed of 2 meter per second, and the remaining half is covered in two parts. And in the remaining half, for half of the time he had traveled with 3 meter per second, and the remaining half is 5 meter per second. So the average speed of the particle in the entire journey. So here we know that the average speed is equal to the total distance by total time taken. So as you see from the previous board or from the previous slide, and you can understand these values of S1 and S2 and S. So if you want to find the value of TAB, it is S by 2, and TBC equal to S1 by 3, and TBC by 2 equal to S2 by 5. Here, because the time equal to distance by speed, so we have got this S1 and S2, but we have known that S1 plus S2 is equal to S. So S1 plus S2 is equal to, if you take a TBC as common in this both, 3 by 2 plus 5 by 2, it will obviously gives 4. So S1 plus S2 equal to 4 TBC. So from this you can write TBC equal to S1 plus S2 by 4, as S1 plus S2 is S, so it is S by 4. So the average speed or average velocity is S1 plus S2 by TAB plus TBC. So as S1 plus S2 is equal to S, so S plus S by TAB S by 2 and TBC S by 4. So and finally we have got 8 by 3 meter per second, which is average speed. So here we have this problem number 18. In the problem number 18, he had given if the velocity of a particle is at plus bt square, velocity is equal to at plus bt square where a and b are constants, then the distance traveled by it in between 1 second and 2 second is t equal to 1 second to 2 second. So, so here a and b are constants. He is asking the distance traveled. We know that velocity equal to dx by dt. That means the velocity equal to the distance traveled by time. So we can find instantaneous speed or instantaneous velocity as dx by dt. From this you can write dx equal to v into dt. So obviously if you apply integration on both sides, then integral dx equal to integral v dt. So as the integration and differentiation will get cancel each other, so it is x equal to integral v dt. So from this you can write the distance x is equal to integral of v into dt. So here v is at plus bt square, at plus bt square dt. So here it is from time of 1 second to 2 seconds. You have to apply the limits from 1 to 2 because he has given the time 1 to 2 seconds. So here the limits are from 1 to 2. So if you apply integration, we know that integral of x power n dx equal to x power n plus 1 by n plus 1. So here in place of x, here we have t. So it is, as a and b are constants, there is no need of integrating the constants. So a into integral of t dt 1 to 2 plus b into integral t square dt, the limits are from 1 to 2. So a into, as t means you can take it as t power 1, so t power 1 plus 1 by 1 plus 1, t square by 2, b into here n equal to 2, so 2 plus 1 by 2 plus 1, t cube by 3. So here a into 2 square, if you apply the first you have to substitute the upper limit. Here the upper limit is 2, so 2 square by, so in place of t you have to substitute the value of 2, so it is 2 square by 2 minus, then you have to substitute the lower limit 1 square by 2 plus b into, in place of t now you have to substitute upper limit which is 2, so 2 cube by 3 minus the lower limit 1 cube by 3. So from this you can write 2 square by 2, 4 by 2, 2, 1 square means 1 by 2 plus b into 2 cube 8 by 3 minus 1 by 3, and finally you will get 2 minus 1 by 2 means 3 by 2, so 3a by 2 plus 8 by 3 minus 1 by 3, 7 by 3b, 3a by 2 plus 7 by 3b. So it is option A. Here we have, this question has come in the previous NEET exam 2016 year. So here you have to understand this problem. So here given v equal to at plus bt square in between the time interval of 1 second to 2 second. From this you can write the instantaneous speed or instantaneous velocity v equal to dx by dt. From this you can write dx equal to v into dt. So now you have to apply the integration on both sides. If you apply the integration on both sides, then integral dx equal to integral b dt. So here integration and differentiation will get cancelled and there remain x equal to integral b dt. So here v is at plus bt square, and you have to apply the limits from 1 to 2 at plus bt square dt. So here a is constant, so a into integral t dt plus b into integral t square dt in between the limits 1 and 2. So a into here t dt it is. So you can take it as t power 1. So here n becomes 1. So t power 1 plus 1 by 1 plus 1. So t square by 2 plus b into t square. So here n equal to 2. So 2 plus 1 3 t cube by 3. So if you substitute, first you have to substitute the upper limit 2. So 2 in place of t square, 2 square by 2 minus, then you have to substitute the lower limit 1 square by 2 plus b into 2 cube by 3 minus 1 cube by 3. 2 square by 2 means 4 by 2, which is 2, minus 1 by 2 plus b into 8 by 3 minus 1 by 3, 3a by 2 plus 7b by 3, which is option A here in the problem number 18. Here in the problem number 19 now. Now we shall look at the problem number 19. In this he has given choose the wrong statement. Here in the statement A, the motion of an object along a straight line is the rectilinear motion. So here it is given as the rectilinear motion. The rectilinear motion means the motion along a straight line path. So it is correct only. Next, the statement B, the speed in general is less than the magnitude of velocity. We have and discussed this point in the previous problem. In the previous problem only. Here the speed is always greater than or equal to velocity. The speed will never be less than velocity. So we have explained that reason with reason also in the previous problems. So you can understand that the speed in general is less than the magnitude of velocity. It is incorrect, wrong statement. Next, see the slope of the displacement time graph gives velocity of the body. So here the displacement time and displacement graph. So always you should take the time on x-axis. So here the time is taken on x-axis and the displacement is taken on y-axis. So the slope of displacement time graph, we know that slope is equal to y by x. So it is s by t here, because on y-axis there is the displacement s and on x-axis it is time t. So y by x gives the slope. So it is s by t which gives velocity. So that statement is also true. Next statement D, the area under the velocity time graph gives the displacement of the body. So here if the graph is drawn in between time and velocity, we know that velocity equal to displacement by time. But from this you can write the displacement as is equal to velocity into time. So the product of velocity and time means here it gives the area under, suppose if the graph is like this, the area under this graph, that means the area under the graph will give the value of displacement s if the graph is drawn in between velocity v and time t. So the negative slope of speed time graph indicates a retarded motion. That means here the negative slope means our speed time graph indicate that speed is decreasing with time. If the speed is decreasing with time, it is obviously the retarded motion. So here the wrong statement is B, because as we know now already, speed is always greater than or equal to velocity. He has given the speed is less than velocity, so that statement B is incorrect. Next you have the problem number 23. Here you have what determines the nature of path followed by the particle. So here, if you take speed, suppose if you want to travel from the Hyderabad to Chennai, from Hyderabad to Chennai. So if you want to travel in between these 2 points or these two cities, you can go by flight, or else you can go by road, or you can go from Bangalore and then to Chennai, or else you can travel by sea. That means first you can go to the Visakhapatnam, from Visakhapatnam to Chennai by ship, or else you can go to an USA and from USA you can come to Chennai. So here, while it comes to the distance, it is simply the path traveled. It will not have any specific direction. It can be any path, so it will not define the nature of path. But velocity is a displacement by time. Here the displacement is the shortest path or the straight line joining these 2 points, or the straight line joining those 2 points. So here the nature of the path, which is straight line, which is indicated by velocity displacement by time. Next, acceleration is change in velocity by time. Acceleration may increase or may decrease, or the acceleration will exist if the body, it may travel in any of the path, the acceleration will exist. So here it is option B which will define the nature of the path, velocity, because it is velocity equal to displacement by time. As the displacement defines the path, so here the velocity, as it depends on the displacement, the velocity also defines the nature of the path. So here we have the problem number 24. In problem number 24, here given the position of a particle moving on x-axis is given by x equal to at cube plus bt square plus ct plus d. So here the numerical values of a, b, c, d are 1, 4, minus 2 and 5 respectively. A equal to 1, b equal to 4, c equal to minus 2 and d equal to 5. So if you substitute these values in this equation, then it becomes a equal to 1, so it is 1t cube, that means simply t cube. B is 4, 4t square. C is minus 2, minus 2t. D equal to 5. So here the displacement or the position, x is equal to t cube plus 4t square minus 2t plus 5. Then what is the velocity of the particle at time of 4 seconds? So here the velocity is equal to dx by dt, we know that. So it is d by dt of t cube plus 4t square minus 2t plus 5. Here the differentiation of any quantity, like in the form of x power n, it is n into x power n minus 1. So here t cube, here n is equal to 3, so it is 3 into t n into x power n minus 1, so it is 3 into t power 3 minus 1 plus 4 t square it is, so 2 into t, 2 minus 1 minus 2 into t power 1, so it is 1 into t power 1 minus 1, and there is no need of differentiating constant. The differentiation of a constant is 0. So it is 3 minus 3 into 3t power 3 minus 1 square 2. So 4 into 2 8. T power 2 minus 1 1 minus 2 into t power 0 1. So it is 2 into 1 2. So this is velocity, but he is asking the value of velocity at time t equal to 4 seconds. So if you substitute t equal to 4 at t equal to 4 seconds, 3 into 4 square plus 8 into 4 minus 2. So 3 into 4 square 16 plus 8 into 4 32 minus 2. So 3 into 16 48 plus 32 minus 2 gives 78 meter per second, which is option A. It is 78 meter per second. It is problem number 24 here. Now we shall see the problem number 25. The slope of the tangent drawn on the position time graph at any instant is equal to instantaneous. Here the graph is drawn in between position and time. As we know that always we have to take the time on x-axis and position x on y-axis. And here the graph is in between the position and time. So here the rate of change of position is velocity. So here we know that slope is equal to y by x. So it is obviously x by t, which is equal to velocity of the graph. So here it gives velocity, option C. Twenty-six wrong. Next we have problem number 27. The displacement time graphs of two moving particles making an angle of 30 degrees and 45 degrees with the x-axis, the ratios of their velocities. So the ratios of velocities. So here given in the graph like this, time and displacement s. So one graph is making an angle of 30 degrees and one is making an angle of 45 degrees. So here we know that slope means y by x. Slope is y by x. So here slope is equal to s by t. But we also know that s by t gives velocity. The displacement by time gives velocity. So here the slope of the graph is equal to velocity. So here from this you can write slope for the angle of 30 degrees graph, tan 30 degrees is equal to 1 by root 3 and tan 45 degrees is equal to 1. So he is asking the ratios. So obviously tan 30 degrees by 1 by root 3 by 1. So it is obviously 1 by root 3 is 1 is 2. Root 3 is the ratios of velocities of the displacement time graph. So here, as we have known that slope is also equal to tan theta, here the slope and the velocities are same. So here the tan theta gives the value of velocity. So here he had given two angles 30 degrees and 45 degrees. Tan 30 degrees is equal to 1 by root 3 and tan 45 degrees is equal to 1. So tan 30 by tan 45, 1 by root 3 by 1. So it gives obviously 1 by root 3, which we can write as 1 is to root 3, option D. Next you have the problem number 28. In problem number 28, the displacement of the body along x-axis depends on time as here the displacement okay. So here the displacement of a body along x-axis depends on root x equal to t plus 1. From this you can write squaring on both sides x equal to t plus 1 whole square. So t square plus 2t plus 1. So here, as he is asking the value of velocity, velocity equal to dx by dt. So d by dt of t square plus 2t plus 1. So again the d by dx of x power n. So t square 2 into t power 2 minus 1, it is obviously 1. So 2t plus 2 into 1 into t power 1 minus 1, 0. So it is 2 only. So we got velocity as 2t plus 2. He is asking whether the velocity is increasing with time or decreasing with time or independent of time. Here the velocity is 2t plus 2. That means here the velocity depends on the value of time t. So it is not independent. It is dependent on time t. So now you have to check whether it increases or decreases with time. For example, take t equal to 1. Take t equal to 1. So v equal to 2 into 1 plus 2, that is 4. If you take t equal to 2, v equal to 2 into 2 plus 2, 4 plus 2, which is 6. So obviously with the increase of time, here the value of v is increasing. So here the velocity of the body increases with time t. It is option A, increases with time. Here problem number 29. Here, which of the following graphs cannot possibly represent one-dimensional motion of a particle? Here, one-dimensional motion of a particle means, here if you see along the graphs, one-dimensional motion is always indicated by a straight line graph. So here, no graph is a straight line, so it is not one-dimensional, it is two-dimensional motion, everything. So all the options are not one-dimensional. So here, option D, all four, which will not represent any of these graphs, does not represent one-dimensional motion. If it is one-dimensional motion, it should be a straight line. So here no graph is a straight line. So obviously all the graphs will not indicate one-dimensional motion. So here problem number 30. If you look at the problem number 30, here you can observe that he is taken a boat which covers a distance of 6 hours moving downstream on a river. Downstream means here the boat is flowing. Suppose if this is a river, here in this river the water is flowing in this direction, for suppose. So he is saying that he had rowed the boat in the downstream in a time of 6 hours. So he had traveled some distance from point A to from point B. Downstream means with the flow of the river. As the flow of the river is in this direction, the boat also is traveled in the same direction of the flow of the river. So if it flows like this, it takes 6 hours. But it covers the same distance in 10 hours moving upstream. That means upstream means it is against the flow of the river. It is against the flow of the river. We know that if you want to row the boat, or if you sail the boat, or if you want to swim across the flow of the river, it takes much time because you have to apply much amount of force and the velocity will get decreased. So it takes time of 10 hours to row upstream. So here if Vr be the velocity of river and Vb be the velocity of boat, while it is traveling the downstream, both the velocity of the river and the boat are across or are along the same direction. If they are along the same direction, you can add those velocities. So Vb plus Vr equal to 6. It takes 6 hours of time. That means the distance, the velocity equal to distance by time. The distance d by time is 6 hours. So in the upstream, velocity of the boat and the velocity of the river are in opposite direction. The velocity of the boat is in this direction and the velocity of river in the exact opposite direction. So it is Vb minus Vr equal to d by 10 because it travels the same distance through upstream and downstream. So as he wants to find the time t, time equal to distance by velocity. Here the total distance traveled by the object is d downstream and d upstream. So d plus d, 2d by velocity. Here the total velocity is so here there are velocities upstream and downstream. So take it as v1 plus v2. So 2d by velocity, v1 is velocity across downstream. So it is distance by time 6, and v2 the distance or the velocity of the boat in upstream direction. So the distance is again the same d, but it takes time of 10 hours. So 2d by d, if you take it as common, 1 by 6 plus 1 by 10. D get cancelled. 2 by 10 plus 6 by 10 into 6, 16. So 120 by 16. 120 by 16 gives 8s, 60s, 2 4s, 2 15s. 15 by 2, which is obviously 7.5 hours. 7.5 hours. So it is option B in problem number 30. Problem number 31. Which of the following cannot be speed time graphs? So here the speed time graphs which cannot be speed time graphs. So here, if you see here carefully, if you see in the graph A, if you see in the graph A, here if you see in the graph A, here with the increase in the time the velocity is increasing, and then the again time is coming with the decrease in time, again it is coming back in the same direction, so which will not happen in case of speed. So it is incorrect. Option B, if you see, it is at the time t equal to 0, the body is moving with some speed, the body is with some speed. With the increase of time, the speed is been decreasing, and at particular instant of time it becomes 0. In graph 3, with the increase of time, the speed is increasing, which is straight line motion. Next, in D, with the increase of time, the velocity is increased to a particular level, and then with the further increase of time, the speed is decreased. Of course, it may happen. In option C, in option E, here the speed is increased up to particular level of time, and after that time it decreases to 0. So here option A is not possible. So here only A is not possible. It is option D. A particle shows the distance time graph given in this figure. This question is wrong. What a graph is wrong. Okay, look at the problem number 34. In problem number 34, here given a train moves from rest. A train moves from rest with acceleration a, and in time not and in time and I take it as time as t1, which covers a distance x. So here a train is starting at rest, that means starting velocity u is 0. With acceleration, it is moving with acceleration a, and in time t1 it covers a distance x, and it then decelerates to rest. It then decelerates to rest. So here, as it decelerates, means acceleration is decreasing, and after traveling some distance the body had come to rest. That means its final velocity v has become 0 in case 2, and it is moving with some acceleration a2 equal to beta. Here a1 equal to alpha, it is not a, it is alpha, and a2 is beta. In time t2, and the distance is y. Then he is asking the relation in between x, y, beta and alpha. So here first, in the first instance or in the first case, the strain is starting from rest and moves with acceleration alpha. In time t1 it reached the distance of x. In the second case, the train finally comes to the rest, that means the final velocity is 0 after the acceleration is beta. In time t2 it traveled a distance of y in the process of coming to rest. So you have a formula b square minus u square equal to 2as. So here in the first instant u is 0, so v square equal to 2as, so v square equal to 2, a is alpha, s is x. Next instance, if you take case 2, again here v square minus u square equal to 2as, but here v is 0, so minus u square equal to 2, a is beta and s is y. But here you have to take, here it is decelerating, the decelerating means acceleration is decreasing, it is minus beta, so it is u square equal to 2 beta y, u square equal to 2 beta y. So it then decelerates to rest at constant deceleration for distance y in time t. So here if you write, b square equal to u square, you can have 2 alpha x equal to 2 beta y. So here from this you can write x by y equal to beta by alpha is the relation between x, y, beta and alpha. So here it is option A, x by y equal to beta by alpha. Here problem number 35 is somewhat important. Look at problem number 35. In problem number 35, here the displacement of the body is given to be directly proportional to the cube of the time. Here the displacement x is directly proportional to cube of the time. X is directly proportional to t cube. The magnitude of acceleration of the body is proportional to. So here if it is directly proportional to t cube, it comes like this. So here if x is equal to t cube, velocity is equal to dx by dt, which is 3t square. Since differentiation of x power n is equal to n into x power n minus 1, so it is 3 into t power 3 minus 1, 3t square. Next you want acceleration. Acceleration equal to dv by dt. So d by dt of 3t square. So it is 3 into t square. 2 into t power 2 minus 1. 2 minus 1 is 1. So 3 into 2t, 60. So from this you have that acceleration is directly proportional to time t. So it is option B in problem number 35. Now you have problem number 36. In problem number 36, at a certain time, a particle has a speed of 18 meter per second and in positive directions 2.4 seconds later its speed was 30 meter per second. So at a certain time a particle has speed of 18 meter per second, and 2.4 seconds later its speed is 30 meter per second. So its starting speed is 18 meters per second. After time of 2.4 seconds its velocity becomes 30 meter per second. The final velocity equal to 30 meter per second, but in the exact opposite direction. In opposite direction means you should indicate it by minus 30 meter per second. Then what is the magnitude of average acceleration of the particle during 2.4 seconds? So acceleration equal to change in velocity by time. So here v is minus 30 minus u minus 18 by time t 2.4. So it is minus 48 by 2.4, which gives minus 20 meter per second square. This minus indicates acceleration is decreasing. So but the actual acceleration is 20 meter per second, but this minus is used to indicate that acceleration is decreasing. So here the acceleration is decreasing at 20 meter per second square. So it is option A. It is option A. 20 meter per second square. Next we have 37. 37. In problem number 37, here the displacement of a particle as a function of time is shown in the figure. It indicates that, so the displacement of a particle is shown in the figure. Here figure is not there. Figure problem wrong. Figure another figure. Next problem number 38. So here the velocity time graph of two bodies A and B are shown in the graph. So here then the acceleration of A and B are in the ratio. As we have done in the previous problem, he had given the graph in between the displacement and time, then he asked the ratio of velocity. Now he had given the graph of the velocity and time, he is asking the ratios of accelerations. So again, he has given the graph in between time and velocity. Time and velocity. So here is given two graphs with angle of 25 degrees from x-axis, the other of 40 degrees from y-axis. 40 degrees from y-axis. So if it is 40 degrees from y-axis, it is obviously 50 degrees from x-axis, because the angle in between x and y-axis is equal to 90 degrees. So if the angle from y-axis is 40, the angle from x-axis will be 50 degrees. So then he is asking the ratios of acceleration. So here again acceleration means here the slope is equal to y by x, which is velocity, the change in velocity by time, which obviously gives acceleration. So here the slope gives us the acceleration. So we can write the slope is also equal to tan theta. So here acceleration of A tan 25, acceleration of A is equal to tan 25 degrees, and acceleration of B is equal to tan 50 degrees. So tan 25 to tan 50 degrees, it is option A. Next problem number 39. In this problem number 39 has given that the acceleration of a moving body is found from the so area under the velocity time graph, and now we have seen that from velocity time graph you can find the acceleration by finding the slope of the velocity time graph. So here in this problem, he had given the acceleration of the moving body can be found from. So here the area under the velocity time graph, and now you have seen that from time velocity graph, you can find acceleration by finding the slope by not the area, because acceleration equal to change in velocity by time t. Next, option B, area under the displacement time graph. So here area under the displacement time graph means, so here we have known that the displacement into time gives velocity equal to displacement by time. So the area under displacement and time graph does not gives the value for acceleration. Next, distance time graph, exactly same. The distance time graph also will not give the value of acceleration. Next, slope of velocity time graph. Yes, we have found in the previous problem only the slope of the velocity time graph gives acceleration. It is option D. It's option D in problem number 39. In the previous problem only we have found the slope of velocity time graph gives acceleration. So here in problem number 40, the velocity time graph of a particle, the velocity time graph of a particle comes out to be a non-linear curve. The motion is, so here the velocity time graph always gives the value of acceleration. So here acceleration is the slope of velocity time graph. So here if the velocity time graph is a non-linear curve, it is non-uniform accelerated motion. So it is option C. If it is a uniform accelerated motion, the graph should be a straight line. So it is non-uniform accelerated motion. #41. So here this problem number 42 model is important, and these type of problems in general will come in the exam. So here given the uh, motion of a particle along a straight line is described by equation x equal to 8 plus 12t minus t cube. 8 plus 12t minus t cube, where x is in meter and t is in second. Here is asking the retardation of the particle when its velocity becomes 0. So here the retardation means negative acceleration. Negative acceleration. And the retardation means the negative acceleration. So the retardation of the particle, he is asking the value of acceleration when its velocity becomes 0. So first you have to find velocity v equal to dx by dt. So obviously it is constant, the differentiation of a constant is 0. 12t, 12 minus 3t square. So here he has given the acceleration of the particle. So here acceleration equal to again dv by dt. So it is 12 is constant now, it is minus 60. Minus 60. So he is asking the acceleration of the particle when velocity becomes 0. So here the velocity should become 0 means 12 minus 3t square should be equal to 0. So 12 equal to 3t square, t square equal to 12 by 3, which is 4. So t equal to 2 seconds. So if t equal to 2, acceleration equal to minus 6 into which is 12 meter per second square. So it is option D here. So here it is option D, which is 12 meter per second square. Next we have the problem of 43. If a particle moves with an acceleration, then which of the following can remain constant? We know that acceleration equal to change in velocity by time t. So which, if a particle moves with an acceleration, then which of the following can remain constant? So which of the following can remain constant mean, so if the body is moving with some acceleration, what does it mean? The body is moving with some acceleration. With constant acceleration means the velocity is changing continuously. Only if there is change in velocity we can say that there is some acceleration. So as he is saying in the question, there is some acceleration. So obviously the so here the speed or the velocity of the body should change. So here the velocity will increase or decrease and continuously. So here velocity will always change. So here velocity will not remain constant at any case, but speed can remain constant if the acceleration is changing continuously, or if the acceleration is remaining constant, only the speed can remain constant. So it is option D, only the speed, in problem number 43. Next we have the problem number 44. In problem number 44, the graph between the displacement and time for a particle moving with uniform acceleration is a straight line, with positive slope. Parabola, ellipse, straight line parallel to the time axis, straight line perpendicular to the time axis. He has not given graph. Graph question wrong. So here we have the problem number 47. In problem number 47, he had given that a particle moves in a straight line so that its displacement x meter in t seconds is given by x square equal to t square plus 1. So here he had given that x square equal to t square plus 1. So its acceleration is So it's x square equal to t square plus 1. From this you can write x equal to under root of t square plus 1. So x equal to t square plus 1 whole power 1 by 2. So he's asking the value of acceleration now. So to find acceleration, first you should find velocity. So the velocity equal to dx by dt. So it is 1 by 2 into t square plus 1 whole power 1 by 2 minus 1. Here we have to do the inner differentiation of t square. So it is 2t. So here half into t square plus 1, 1 by 2 minus 1 minus 1 by 2 into 2t. So 2 get cancelled. Next, acceleration. Acceleration equal to dv by dt. So it is minus 1 by 2 into t square plus 1 minus 1 by 2 minus 1 into, so here from this we have x square equal to t square plus 1. You can write 1 by 2 into minus 1 by 2 into x cube whole power minus 1 by 2 minus 1 minus 3 by 2 is x square. T square plus 1 is x square. So it is if you again undifferentiate it, it becomes 1 into, so this both get cancelled, it becomes 1 by x cube. It is proportional. It is here the acceleration is directly proportional to 1 by x cube. Option A it is. Here next in the problem number 48, he had given the position time graph for motion with zero acceleration. Zero acceleration means constant velocity. Here the constant velocity means there should be the change in displacement with respect to time t. Here in problem number 48, so here the position time graphs are being given A, B, C and D with zero acceleration. So first of all you should understand when the graph is in between the position and time with zero acceleration. Zero acceleration mean constant velocity. The body should move with constant velocity. If it is moving with constant velocity, the displacement will always increase with respect to time. So here there should be constant increase of the displacement. If it is constant increase of displacement, there should be a graph with positive slope. So here if you see from this graph, the graph C has the positive slope. So here it is option C, which has positive slope in between x and t graph. In problem number 49, he has given the area under velocity time graph uh, in a given interval of time. The area under velocity time graph. So here that means he is asking velocity into time. So we know that acceleration equal to or velocity equal to displacement by time. We already know that the slope of the graph will gives the value of acceleration, because acceleration equal to velocity by time. So here the slope of this graph will give acceleration. So it is not acceleration because he is asking the area. So to find area, you can write here v equal to the displacement by time. So here the area under the velocity time graph means velocity into time. From this you can write the displacement equal to velocity into time. So velocity into time graph, its area gives displacement. So it is option E. Wrong. That's 5 minus 3. So here problem number 51, if a graph is drawn in between the velocity and time for the motion of a particle, the area under the curve represents so velocity and time. So the graph in between the velocity and time, as we have seen in the previous graph only. So the area under velocity into graph, velocity and time graph, that means the velocity into time gives displacement. So it is displacement of the particle B. In the problem number 53, has given the acceleration A of a body starting from rest varies with the time following the equation A equal to, here the acceleration A equal to 3t plus 4. Acceleration A equal to 3t plus 4. Next, the velocity of the body at a time t equal to 2 seconds. The velocity of the body at time t equal to 2 seconds. So we know that acceleration equal to dv by dt. So from this you can write dv equal to acceleration into dt. If you apply integration on both sides, so integral dv equal to integral a into dt. If both integration and differentiation get cancelled, v equal to integral a into dt. So integral 3t plus 4 dt. So you can write from here, but in between, okay, the velocity of the body at time t equal to 2 seconds. So if you apply integration, we know that x power n equal to x power n plus 1 by n plus 1. So it is 3t power 1. So 3t power 1 plus 1, 2 by 2. So 3t square by 2. So 4 into t power 0, 0 plus 1, 1 by 1. So it is 4t. So this is value of v. Now he is asking at a time t equal to 2 seconds. At 2 seconds what happens? So 3 into 2 square by 2 plus 4 into 2. 3 into 2 square, 4 by 2. 3 into 2, 6 plus 4 into 8, 6 plus 8, 14 meter per second is the value of v, the velocity. So it is 14 meter per second. For problem number 53, it is option C. Option C. Now we have the problem number 54. In problem number 54, the figure given shows the distance time graph of a motion of a car. It follows x from the graph that the car is at rest or in motion, whether it is an uniform or non-uniform motion or uniformly accelerated. So here the graph is in between x and time t. So x and time t here for for some instant of time t. So here the displacement x is this much, and if the time is further increased, the displacement is been increased, and the displacement is been increasing at non-uniform levels. As the displacement is increasing at non-uniform levels, so obviously the velocity is also non-uniform. If the velocity is non-uniform, then there is acceleration, because acceleration is change in velocity. So here the velocity is non-uniform means the velocity is always keep changing. So if the velocities keep changing means acceleration exists. So here it is to be the uniformly accelerated motion, x equal to 1.2 t square, because x equal to 1.2 t square, velocity dx by dt equal to 1.2 into 2t, that is 2.4 t. Acceleration a equal to dv by dt, it becomes simply 2.4. So here the value of acceleration is constant, so it is uniformly accelerated. Option D. And look at the problem number 56. Here in problem number 56, in problem number 56, here the velocity time graph of an object is as shown. So this is the graph in between b and t. So here the displacement during the interval 0 to t4 is. So here we know that if the graph is in between velocity and time, velocity and time, the displacement is can be found by finding the area under the graph. Area under the graph. So he is asking the displacement up to T4, 0 to T4. So here the graph is in this manner, the velocity, time t, up to T4 he is asking. T1, T2, T3 and T4. Now you have to find the area under this graph. So up to T1 it is triangle, up from T1 to T2 it is a rectangle, from T2 to T3 again it is rectangle or a square, T3 to T4 it is again rectangle. So here the total displacement under this velocity time graph is given by area under A plus area under B plus area under C plus area under D. So area under A plus area under B plus area under C plus area under D gives the value of displacement. Because I am saying here again, see once, here velocity equal to displacement by time. Displacement by time, you can write displacement equal to velocity into time. So here the area under VT graph gives displacement. So here from 0 to T4 it is area of A plus area of B plus area of C plus area of D. So here, but here in this case what happens, here A is positive, B is negative, C is positive and D is a negative. So here the area under block A, that is a triangle, it is positive. The area under B, which is a cube or a rectangle, it is negative. The area under C is positive again, and the area under D, which is a triangle, it is again negative. So it is area under, as it is the negative, so you have to add all this. So area under A minus area under B plus area under C minus area under D. So here with this the option is B, area of A plus area of C minus area of B minus area of D. It is option B for problem number 56. Now we have the problem number 58. In problem number 58, and here given in the problem number 58, your body is freely falling. Your body is freely falling under action of force of the gravity. So here if the body is falling freely, the distance covered by the body in first, second and third minutes of its motion are in the ratio. The distances traveled by the body in the first second and the third second are in the ratio. So here is asking like this: if the body is freely falling from certain height to the ground, so here in the first second it will travel some distance. After 2 seconds it will travel some distance. After 3 seconds it will travel some more distance. So he is asking the distances traveled in the first second, and he is asking the distance traveled only in the second second. That means you have to consider from here to here only. And next the distance traveled in the third second. The distance traveled in the third second. Here the distance traveled in the second does not mean the distance traveled in the 2 seconds. It is the distance traveled in the second. So that means here you have to take this distance. And if the distance traveled in the third second means you have to take this distance. So here as the body is freely falling, you have the S is equal to ut plus half at square. If the body is freely falling, the starting velocity u should be taken as 0 always. So u is 0, s is equal to ut plus half at square. As the body is falling under the action of gravity, a becomes g, so it is half gt square. So as u is 0, s becomes half gt square. As we know here, the value of g is 10. So here s1 equal to the distance traveled in the first second is equal to half g is 10, t is 1, because it is the time traveled in the first second. In first minute, okay, in first minute, t equal to take 1. So 5 into 1 square, 5 into 1, 5. Next term, s2, half g is again 10, t in the second. So that means here s2 gives the distance traveled in the 2 seconds. So it is 2 square. 5 into 4 gives 20. Next, the distance traveled in the 3 seconds. In the 3 seconds, 10 into 3 square, 5 into 9, 45. But he is asking the ratios in first, second and third seconds. So here in the first second it traveled 5 meters for suppose. In S2, in 2 seconds it traveled 20. In 2 seconds it traveled 20. In 3 seconds it traveled 45. So, but he wants the ratios in the first second, second and third second. So, if this is 5, this part would be 20 minus 5, 15. And this part would be 20 minus 5, 15. And this is 45 minus 20, 25. So, here it is 5 is to 15 is to 25. It is obviously 1 is to 3 is to 5. It is option C. A man is at a distance. Problem number 60. Here he has given a man is at a distance of 6 meters from a bus. The bus begins to move with a constant acceleration of 3 meters per second square. In order to catch the bus, the minimum speed with which the man should run towards the bus. So here the man is at a distance of 6 meters. Here the bus begins to move means its starting velocity u is 0. After then it starts moving with an acceleration of 3 meters per second square. Next, in order to catch the bus, the minimum speed with which the man should run. So here, if his starting velocity u is 0, he is asking the velocity with which he should run. That means he is asking the value of final velocity with which the man should run to catch the bus. We have v square minus u square equal to 2as. So here we know that here we know that s is equal to 6 meters. So v square minus 0 equal to 2 into 3 into 6. So v square equal to 6 into 6, 36. V is obviously 6 meter per second. It is option C in problem number 60. Sorry, stop this. ఇప్పటికి దాదాపు 2 hours అయిందా? ఐ థింక్ స్టాప్ చేసాను.